This video is about salinity and how to interpret salinity changes on the Trellis Dashboard App. And in our soil, the majority of our salts are coming from parent material, which is simply the geological material that forms in the soil profile. Salts also form through over-fertilization. In some cases, and in sometimes unknown cases, we do have salts in our irrigation water, which is why having a device to monitor salts is so important. So what high salinity can do is it can trick the plant into thinking that the soil is drier than it really is. When that happens, you have less suction, which will cause the plant to uptake less water. So you have this nutritional imbalance with excessive uptake in salts. Our Centec sensor stations are able to monitor salinity movements and electric conductivity data on our graphs. And because these changes are so dynamic, really the best thing to look at is the 5 to 10 day salinity trends. This purple line that is showing so much variability is the 2-inch mark, and this bottom line here is the 26-inch mark. This graph here is overlaying our soil moisture with our soil salinity to see what we can expect as moisture goes up and down. So this darker purple line, the one that is trending down, is our soil moisture, and you can see as the soil moisture goes down, our salinity goes up. As our moisture goes down, our salinity goes up. And that is a trend that you would expect. So our solutes increase when moisture decreases or during high evapotranspiration times. And so the lower the moisture, the higher the salinity, and vice versa. There are times when solutes will move with moisture. You can see here at the 18-inch mark, you have what you would expect. The solute is flushing as the moisture increases here on the 16th. But at the 26-inch mark, the solutes are increasing with this rain event. All solutes will have different solubility depending on their chemistry. Some will bond with particles for days as the soil dries and become mobile again as the soil gains moisture. So these salts are constantly in a state of fluctuation. So as the upper layers lose solutes to gravity, the layers below will gain them, and that's what we're seeing here. Over time, all the salts will be flushed through the soil profile, but again, that rate depends on the solubility and the volume of water that's going through. So as fertilizer is implied, a layer will increase in solutes, then it holds them and releases with successive rain events or wetting events. Or this could even happen, it could be so dynamic that this happens over the course of a single wetting event. What this means to the producer is that they're seeing the movement of fertilizer. If the lower layers spike, then drop past original levels, solutes are flushing past that lower layer, which could be a waste of input if it's at the bottom of the root zone.